So good morning students. I hope everybody is energetic to start today's class, and today we will be discussing the chapter Newton's laws of motion along with the topic friction and circular motion. Okay, so let's see what are the topics in this chapter. You can see that basically we have to learn about free body diagram. Okay, other than that, applications of Newton's laws we will learn friction and circular motion. Okay. First topic, that is Newton's equations of motion. Equations of motion you have been using since 9th, I guess. So you know this equation, that is V is equal to U plus AT, S equal to UT plus half AT square, and V square equal to U square plus 2AS, or in this alternate form, that is V square minus U square equal to 2AS. So I hope all of you know these three equations. We need these equations to solve the problems, even though we are applying free body diagram, Newton's laws concept in them. We need these basic equations to solve the questions. Okay. Coming to Newton's laws, there are three laws of motion we know, plus one law of gravitation. But now gravitation law we will discuss in the chapter gravitation. Let's talk about first three laws. Okay, in that you can see that first law, a body at rest continues to remain at rest, and a body in motion continues to move with uniform velocity unless an external force is applied. Okay, an external force should disturb the system to change its state. Okay, if something is kept on a table, it will sit there until an external force is applied, or if something is moving with a uniform velocity, it will continue to move until an external force is applied. But one word is missing here. You know what that is? External unbalanced. Okay, unbalanced force. Just because an external force is acting doesn't mean it will change the state, because imagine you kept something on the table, an external force is acting there. What is that? mg, acting downwards, but our normal force is there opposing it and balancing it, which is why it is not moving. Now if you push it, that is an external force and it is not balanced, it is not cancelled out. That's why it will move. Okay, so this word is important here, unbalanced force, and this describes the term inertia. Okay, so from the first law we will learn about inertia. And what is inertia? Inability of a body to change its state by itself. Okay, if a body is at rest, it cannot change its state by itself. An external force should act on it. Okay, then coming to the second law, an external applied force is equal to rate of change of linear momentum. So here also it is unbalanced force, and unbalanced force should be there if there is rate of change of momentum in the body. If there is no momentum change, there is no external unbalanced force. So this describes the equation that F equal to ma. How are we getting this equation? F is equal to dp by dt. From this we are getting the equation F equal to ma. So this describes the relation between force and linear momentum. Third law, every action has an equal and opposite reaction. Greatest example for that, you just walking. So when you are walking, your feet is pushing the ground forward and ground is pushing you, feet is pushing the ground backward and ground is pushing you forward. So that is equal and opposite action. It is not cancelling out, because action is happening on one body, reaction is happening on other body. So only if equal opposite force act on the same body, it cancels out. Okay, that's why action reaction force does not cancel out. I hope everybody understood first three laws. Now these are Newton's law. Now let's go to next topic, that is impulse. Why I added a big slide for this topic is because people misunderstand what is impulse. Impulse is not a force. Impulse is change in momentum. Okay, Impulse is change in momentum. So if somebody asks you to find impulse, you have to find a delta P. And why force acts here? We know that force equal to dP by dt in infinitesimal change. If it is a finite quantity, we can write it as delta P by delta T. Okay, that's why to find impulse, we can find impulse equal to F into delta T, that is change in momentum. I hope everybody understands this. Impulse is change in momentum, not a force. Okay, and impulse, we call it impulse when the momentum change is happening in a very short time. Okay, momentum change will happen in a very short time, force will be acting on it, and momentum change happens in a very short time. That's why it's called as impulse. Okay, next one. So let's put this new knowledge into test. A batsman hit back a ball straight in the direction of bowler without changing its initial speed of 10 meter per second. Mass of the ball is 0.12 kg. Determine the impulse imparted to the ball. So we have to find the impulse in this question. So let's see. The ball is coming in this direction with 10 meter per second. So without changing the speed, the batsman hit. So after hitting the bat, ball is going back in the opposite direction with 10 meter per second. You have to find just momentum change here. So change in momentum is equal to m into delta v, right? Because mass is not changing, only velocity is changing. Is velocity changing? Can somebody say? Somebody already answered. Very good. Okay, so see, mass is equal to 0.12 kg. Change in velocity. Initially it is coming towards positive direction, then it is going in the negative direction. So minus 10. I am assuming that towards left is negative, towards right is positive. So final minus initial, that is plus 10. So this we will get as minus 20 into 0.12. Okay, multiplying this, what we will get? 1.2 into 2, that is 2.4. 2.4. Yes, that is Newton second unit, because impulse is equal to force into time, that is Newton second. So this is the answer. I hope everybody understood this. Okay, so in this case, like negative sign is there, you can use the negative sign or not use the negative sign. Magnitude is what mostly matters here. Okay, because direction and all we are assuming which side is positive, which side is negative. So the negative sign doesn't really matter. Okay, is there any doubt in this question? I hope not. So we will move to the next one. 2.4 Newton second. Next one, what are the common forces we will be dealing in mechanics? You know, you have studied so many forces, that is gravitational force. In 12th, if you are saying electrostatic force, magnetostatic, magnetic force. Other than that, some of the forces we learned in 11th, you might have forgot, are normal force, frictional force, tension force and spring force. Okay, difference between these, weight is nothing but gravitational force, okay, mg. Thing is that gravitational force, electrostatic force and magnetic force, they are field forces. Okay, so there is no actual contact between the bodies for the force to be applied. But when you talk about normal force, friction force, tension and spring, they are contact forces. Bodies need to be in contact so that this force should be applied. So if you have any doubt regarding any of this force, we will be seeing them in the like coming questions. Okay, don't worry about them. And normal reaction is nothing but any surface, two surfaces are in contact with each other, perpendicular to that surface there will be a force, that is normal force. So if you are thinking about keeping something on the table of mass m, downward force is mg, right? But it is not falling down, it is staying there. So something is balancing out. So perpendicularly in upward direction, normal force is there and it is cancelling it out. Okay. Similarly, let's say there is a wall and you are applying force on the wall to hold something. Okay. So mg is acting downwards, F is acting in this direction, both are getting cancelled, right? How? Cancelling out F, there is normal force cancelling out F in perpendicular to the surface. Parallel to the surface there is frictional force acting, which is cancelling out our mg. Okay. So this is the basic idea regarding all the forces. Spring force, I hope you know, like right in this chapter we won't be dealing that much. Coming to SHM and all, we will discuss more about spring force. Now, how to draw free body diagram? We will be given a system, right? So draw a sketch of the system. In that, identify all the external forces on the system. Okay, so there are very different type of internal forces also acting, like intermolecular forces, van der Waals forces, such things. We don't have to consider any of them. We only consider external forces acting on it and represent the forces with the direction on the system. Then keep repeating these two like separately. For here there is only one mass here. mg is acting downwards, normal force is acting upwards, frictional force is acting in this direction. Okay, so these are the forces. We are assuming that an external force F external is in this direction. Okay, so cancelling it out, frictional forces in this direction. Similarly, if two masses are there, for two masses we have to draw these like external forces separately. Okay, that is what free body diagram means. And what is the use of this? We will use this to solve, like any unknown quantities will be there, to find that we need these. Okay, let's see. Try to draw this, answer this question. A block of mass m, this is block of mass m, is suspended with two strings as shown in the figure. Draw the free body diagram of the block. Okay, so this is mass m and it is having angle theta with this string and this string is connected like this. Try to draw the free body diagram. I will give you like 1 minute. Then I will show the answer. Okay, so in this what is happening is that this is mass m, we are isolating it. In this mg is acting downwards. Okay, and there is, let's say, tension T1 in this direction due to this thread and the other string is in this direction, so there is T2 in this direction. As we know that this angle is theta, it is given in the question, so this will become T2 cos theta and in this direction it will become T2 sin theta. Okay, this is resolution of components. So vectors you should know very well to study this chapter. Okay. After resolution of components, what we will do is that we will equate the forces horizontal and vertical. Since it is in equilibrium, it is not moving, we can say that T2 sin theta will be equal to mg, because mg acting downwards, T2 sin theta acting upwards, they should be cancelling out. Then T1 acting in this direction, T2 cos theta acting in this direction, so they are also cancelling out. We can say T2 cos theta equal to T1, and comparing this, whatever we want to solve, we can solve. Okay, so this is how we approach the question. Is there any doubt in this? Anyone? Is it audible and visible for all? Okay. So let's try one more question. Draw the free body diagram of both masses and pulley for the given system. Okay. So I am taking this as mass 1, this as mass 2. For mass 1, mg is acting downwards here, and upward direction tension is acting. So upward direction tension T. See, if the pulley is given as frictionless and massless, in that case the whole string will have same tension. Imagine you and your friend are pulling from both sides of a string. If you are pulling and he is pulling with the same force and it is in equilibrium, the whole string will have the same tension on it, right? So it is the same string, then it will have same tension on both ends. So this will also having T tension. Okay. So for mass 2, if I am taking, this is 1, this is 2, if I am taking, mg is acting downwards, that is there. Then since it is sitting on a surface, normal reaction will act upwards. Okay. Then tension is acting in one direction, T. Okay. So this will be free body diagram for our mass 2. Now if you take pulley, the pulley is here. Since it is massless, we don't have to consider mg of the pulley. String is in this direction, so T is acting in this direction and T will be acting in this direction. Okay. So resultant force on pulley will be somewhat in this direction, that is root 2 T if you want. That is just extra point. Okay. Is there any doubt in this one? Anybody? No. Okay. Then we will continue to the next one. Equilibrium of a particle means all the external forces acting on it, if we add, total sum will be 0, which means net force F net will be equal to 0. That is what meant by equilibrium. So in the previous two cases, first case body was in equilibrium, it was not moving, all forces will cancel each other out. In the previous case, in this case it is not said it is in equilibrium. Okay, if either mass will fall down, okay, or it will be in equilibrium, both are possible. If frictional force is there opposing T and it is equal to T, means it will be in equilibrium. If friction is not present, this thing will fall down and it will be a moving system, not in equilibrium. Okay, how to address those different systems we will see in the coming questions. First one, like when it is in equilibrium. Okay, a block of weight 100 Newton is suspended from a rope tied from two ropes at point O. Okay, one rope is horizontally attached to the wall, other is fastened to the ceiling. Angle between ceiling and rope is 60 degree. What are the tension in each ropes? Assume the weight of ropes and knot are negligible. So rope and knot is having no weight, negligible weight. We have to find what is the tension in each rope. Okay. So let's see. I will be drawing in this only for our easiness. Here if you see, weight W is acting downwards. Okay. And tension T is acting upwards. So can I say that T equal to W? right? Because it is in equilibrium, it is not moving, so tension should be equal to weight, right? And this rope is being pulled here, so here tension T is acting downwards. Now if we are assuming this is tension T1 and this is tension T2, okay, now at that point only we have to find the resolution. So this is the point O, T is acting in this direction, T2 is acting in this direction. As you can see, T1 is acting at an angle. We want all the forces in vertical or horizontal direction, but T1 is acting in a angle. So what we will do is that this is T1. If this angle is 60 degree, can I say that this angle is 60 degree? Which rule is that? Alternate interior angles. Do you remember? So by alternate interior angles, I can say that this angle is 60 degree, and based on that I can say if this is 60 degree, this one will be T1 cos 60, and in upward direction there will be T1 sin 60. I hope you understood this. Okay? Yes. So from this we know what is T. T is equal to W. So can I say that T will be equal to T1 sin 60, which means T1 equal to T by sin 60, right? So what is T? T is our weight, that is 100 Newton. So that is W by sin 60 or 100. Sin 60 equal to root 3 by 2. So that will be equal to 200 by root 3 Newton. T1. Okay. Next, this T1 cos 60 in this direction, T2 in that direction. From that I am writing T2 is equal to T1 cos 60. T1 we found here 200 by root 3. So T2 will be equal to T1 200 by root 3 into cos 60. What is cos 60? That is equal to 1 by 2. So this will be 100 by root 3 Newton. If you want, you can substitute root 3 equal to 1.71 or 72. Substitute this value and you can find further also, but I am stopping here. Okay. So this is the method to find tension T1 and T2 when the body is in equilibrium. Is it clear? Mic is mute. Oh, sorry. Hello, since when mic is muted? What is the last thing you heard?
T2.
Okay. So T2 and T1 cos 60 are opposite to each other. We equated that, and T1 we found from here. Substitute that here and we will get what is T2. After that, root 3 equal to 1.72 you can substitute and find further also, but I am stopping here. Is this fine? So when a body is in equilibrium, we draw the free body diagram and we find all the components in vertical direction, horizontal direction separately, and we equate them. That's how we solve in equilibrium case. Okay, I hope there is no doubt in this. Okay, next one. So this is the final answer. It's okay. Now, two blocks of equal masses M are tied to each other using a light inextensible string, which means it is not like a rubber band. If you pull it, it will not stretch. And one block is pulled along the line joining them with a constant force F. Find the tension in the string joining. So you have to find tension T on this string. That is the question. Can you find? So here the approach is little different. Okay, so F force is acting in this direction for A and T is acting in opposite direction. Downward direction there is mass of A into G, upward direction there is normal force. Okay, that is same as mg. Here tension is acting in this direction, downward direction mg is there, upward direction normal force is there. So normal force and mg are cancelling out. That is why there is no motion in vertical direction. The whole system is moving in horizontal direction only because of force F. So what we do is that since F is pulling A and B, so we can say that F is equal to mass of A plus mass of B into acceleration A. If I am pulling A and B together, both will have same acceleration, right? So that is A. Then we can say that since MA equal to MB, F equal to 2MA, which means acceleration A equal to F by 2m. Okay, we will bring till there. Then we can see that B is only having one unbalanced force, that is tension. B is being pulled because of tension, right? So tension is equal to force on B, that is mass of B into acceleration. B is being pulled with only one force, that is tension. So tension equal to mass of B into A. So we can substitute mass of B as m, A as F by 2m. Cancelling m and m, we will get T equal to F by 2. Did you understand this? Last slide, which one you want? This one. Supriya? Okay. So here what we did is, in equilibrium position we are not equating like equal to MA. We are just putting that vertical forces are equal and horizontal forces are equal. When the body is moving, we will equate the forces. Okay, then put equal to, total equal to mass into acceleration. That is what we do in if the body is not in equilibrium. Okay, so I hope this is okay for Supriya. Now see, in case if friction was there, okay, if friction was acting in this direction, then we will say that T minus friction. Why? Because like B is moving in positive x direction. Positive x direction, T force is acting, friction is acting in opposite direction. So T minus friction is mb into acceleration of B. Like this we will substitute. Okay, so this is how we do if the body is not in equilibrium. Is that clear for all? Did not understand? Okay, what is happening is that B is moving, but like friction force is there. Then B is moving in this direction, right? So we will put acceleration of B in this direction. Then tension is pulling it, friction is opposing it. So net force F net on B is equal to tension minus friction. This much did you understand? Okay, net force on B will be tension minus friction. This F net we are writing as mass of B into acceleration of B. Okay, F net, F equal to ma, so it is of B, so mass of B into acceleration of B. That's how we will equate. Is it clear now? Okay, then we will move to the next topic. Next is conservation of momentum. If momentum is changing, we know force is there. But what if there are multiple systems, like multiple particles in our system? Like for example, take this. This is object A and this is object B. Both are moving with initial velocity UA, UB in positive x direction. But it is given that UA is greater than UB, which means A is moving faster. So what will happen? A will hit the B in some time, right? Now, when they hit, what happens? There was like at that moment there is a momentum change will happen, and finally A will move with VA velocity, B will move with VB velocity in positive x direction. Then again, so what happened is that there was force exerted on each, but the momentum of before the collision, total momentum after the collision of both together will be same. Even though momentum changed, in individual velocities changed, that for the total system, if you see, momentum will be conserved. That's what they are saying here. Okay, initial momentum MA UA plus this is MB VB. Okay, this is initial momentum. Final momentum is this is MA VA, and this is correct. Okay, so final momentum is MA VA plus MB VB. So initial momentum and final momentum, they are equal to each other. So initially, before collision, what was the momentum of system? Total momentum, not individual particle. Total momentum will be equal to final momentum. And force, if you see, both force will be, magnitude will be same. Direction will be different, but magnitude will be same for both forces. Doesn't have to like put too much, don't overthink this topic. Just initial momentum, final momentum of the system equal. Now let's put this into a question. A bullet of mass 5 gram is shot from a gun of mass 5 kg. Muzzle velocity of the bullet is 500 meter per second. Muzzle velocity means just when it is released from the gun. It is 500 meter per second. What is the recoil velocity of the gun? So if you think this is gun, this is having 5 kg, 5 kg, and bullet which is having 5 gram. Okay, this is initial. Both are at rest. The bullet is inside the gun. Okay, so both are at rest. Initial momentum will be what? Total mass into total velocity. It is not moving, so velocity is 0. So initial momentum is equal to 0. Okay, now when it is fired, it is having 500 meter per second velocity. So bullet is moving forward. Let's assume that this is having some velocity v in this direction. So final momentum, if we are taking final momentum, if we are taking PF, that should be what? PF equal to mass of bullet into velocity of bullet plus mass of gun into velocity of gun. Okay, substituting here 5 gram 0.005 kg times 500 meter per second velocity plus mass of gun 5 kg into v velocity. Okay, this is final momentum. We have to find v. How to find? We equate PF equal to PI. So initial momentum equal to final momentum, which is equal to 0. If it is equal to 0, can I say that V is equal to 0.005 into 500 divided by 5 minus sign. Okay, can I say this? Anyone? So answer will be what? 0.5. How? 5, sorry. 0.5. 0.5 meter per second. Okay. And this negative sign is there, so minus 0.5. We assumed direction of V in this direction. Negative sign comes means direction of V is this. So when the bullet is moving forward, the gun will move backward with 0.5 meter per second velocity. Okay, that is called as recoil of gun. I hope you understood the concept, conservation of momentum. Is there any doubt? Okay. Yes. Okay. So negative sign just means that the direction we assumed was wrong. Now coming to friction, there are two types of friction, static friction and kinetic friction. Static friction means when the object is not moving. Then you should see, like, if it is not moving, why friction should act. Imagine that there is a huge box, okay, or gas cylinder. You are trying to push it with your one finger. It will not move. Why? Because friction is there between gas cylinder and the floor. Now once it start moving, again you have to keep on pushing it because still friction is acting. Then once it starts moving, kinetic friction will act. Okay, if you are applying force, something is not moving, static friction is there. Something is moving and you have to keep on pushing it to keep the uniform velocity, kinetic friction is acting. Okay, that is the basic idea. Now static friction opposes impending motion. Impending motion means we are trying to move it, right? So we want it to move. That impending motion static friction is opposing, and its value will be equal to F external. Static friction value will be equal to F external. Why? Because let's say there is a cylinder. I am trying to move it with one finger. It is not moving. So whatever force, let's say I am applying 1 Newton. The static friction is equal to 1 Newton there. Now I apply with the whole hand. Still it's not moving. Let's say I am applying 5 Newton. At that time the opposing force is also 5 Newton. That's why it's not moving. Like that, from 0 till a maximum value, static friction will increase. So static friction can have value 0 to maximum value. Okay, F max. This maximum value, static friction maximum value, is equal to mu s into n. Okay, mu s is coefficient of static friction, n is our normal force. So maximum it can go up to that point. After that point the body will start moving. Once the body starts moving, kinetic friction starts. And here you can see kinetic friction occurs when two surfaces are moving relative to each other. Okay, why is it like relative to each other? Let's see that there is two mass MA and MB. Okay, I am pulling this MA. Okay, it is both bodies are moving together. Then there is frictional force between this surface and MA. But if you consider MB and MA, if MA is moving, MB is moving along with it. There in between them, in between that surface, there is no motion, which means here kinetic friction not there. What is the friction acting there? Like between them two surface it is not moving, which means static friction is acting there. Kinetic friction will not act between B and A. Kinetic friction is there between surface and A. Understood? Understood the difference? Why Pi is equal to Pf? That is what conservation of momentum means. Okay, when there is no external force, initial momentum should be equal to final momentum. Okay. Which part you did not understand? Somebody put a thumbs down.
Ma'am, difference between friction.
Difference between?
Both the difference friction.
Static friction, object is not moving. Okay. Kinetic friction, object is moving, which means in this case both friction are acting. Between this surface and mass A, kinetic friction is acting because surface is there, mass A is moving. So in that surface motion is there, so kinetic friction will act. Now comparing this surface, okay, mass A and B, between mass A and B, if you see, A and B are moving together. In between them there is no relative motion, right? Which means there will be no kinetic friction here. Here it will be static friction. Is that clear now? Okay. Now, and kinetic friction is also having same formula, Fk equal to mu k into n. But here kinetic friction, like coefficient of kinetic friction will come. There it is coefficient of static friction. Now, like if some applied force is there, F in this direction, opposing force is kinetic friction, we can say that F net will be equal to applied force minus kinetic friction. Okay, this is what we did before. So F net will be equal to mass into acceleration, total force, mass into acceleration. That will be equal to applied force minus frictional force. Okay, so this is how we have to apply friction into our formula. Okay, I hope this is clear for all.
Ma'am,
Yes.
please remove that tools that from there.
Okay. Is it visible now?
Yes.
Okay. So this is same thing what I told you before. Static friction will increase from 0, and as applied force increases, static friction also increases. But it will reach a maximum value, that is also called as limiting friction. I am not confusing you with names. So there is a maximum value of static friction. After that, body will start moving. Then instead of static friction, kinetic friction will act. Okay. So this is the graph between friction and external force. As you can see, maybe you can't see properly. So friction is increasing from 0 to a maximum value. This is the maximum value. Okay, and this region, it is static friction. When it is linearly increasing from 0 with applied force, that is static friction. This maximum value is called as limiting friction, and it is equal to limiting friction, or maximum value of static friction is mu s into n. After that point, the body will start moving, then kinetic friction will start acting. Static friction will stop and kinetic friction will start acting, and kinetic friction is equal to mu k into n. So formula is same, only coefficient changes. So it is simple to learn. Okay, and from like experiment we have found that coefficient of kinetic friction, okay, is less than coefficient of static friction value. It can be equal, but it will not be more. Okay, is there any doubt in this topic? What is N? N is normal force. Okay, N is normal force. In each case, what the value of N will depend on each case. Okay, case by case we have to find that we will do when we are doing the problems. Now, one just extra point only, there will be no calculation part in this, that rolling friction is very less than kinetic friction or static friction. So our rolling friction less than kinetic friction less than maximum value of static friction. Okay, this is our relation will come. For example, if you are trying to push a cylinder, it will be like you need to apply more force, but if you put it horizontally and you are rolling it, you can easily move it. Okay, so that's why rolling friction is less than kinetic or static friction. Now, frictional force does not depend on area. That is a like common misconception, that if area is more friction. No, frictional force does not depend on area of contact. Okay. Ma'am, explain self-adjusting force once. Self-adjusting force, that's what I meant. See, let's assume that there is a chair here. I am trying to move this chair from the floor. Okay, then if I am applying 1 Newton, it will not move. If I apply 2 Newton, it will not move. Why? Because that static friction is adjusting itself, opposing it. So, for example, there is a box. I am applying 1 Newton to it. It is not moving because friction is acting in opposite direction. Static friction, it will cancel it out. So here static friction will be equal to 1 Newton. Next, same box I apply 2 Newton. Again friction is opposing it. It is not moving. Friction will be there, right? This time frictional force will be equal to 2 Newton. Like that, if I increase external force, static friction increases itself and it will reach up to maximum value, then the body will start moving like that. That is self-adjusting force means. Okay, let's try one problem. An object of mass 1 kg slides down an inclined plane at 30 degree with constant velocity. Determine coefficient of kinetic friction. Here we will apply all the concept we studied right now. Okay, so listen very carefully. If you did not understand a single point also, ask me. Okay, so there is a inclined plane. Inclined plane means like a wedge. This angle is given as 30 degree. An object is there and object is sliding down. That's what they said, right? So first we have to draw all the external forces acting on it. Let's try. Okay. We know that mg will act downwards. Okay, mg is acting downwards. This is the only external force, right? Other like non-contact force, only mg is non-contact force. And since it is in contact with this surface, normal force will act perpendicular to it. That is N. Okay, mg acting downwards, vertically downwards, perpendicular to the surface, N will be acting. Okay, then they said that friction is there because we have to find coefficient of kinetic friction. So since it is sliding down, it is moving in this direction, frictional force will act in upward direction. Okay, and this will be our net force. Net force is in downward direction. Is it clear? now we have to separately find other things. Now see, this is our mass m, mg in this direction, normal force in this direction, and frictional force in this direction. If you see, object is moving in this direction, right? So instead of taking our vertical and horizontal like this, I will consider this as my vertical direction and this as my horizontal direction. Okay, instead of like plus like this will be our x and y direction. Assuming that we can resolve mg into the components. So one component of mg in vertical direction, another component of mg in horizontal direction we will assume. Since this angle is 30 degree, okay, this angle will be 60 degree, right? So this angle will be 30 degree. Okay, do you have any doubts there? Like if you drop this will be 60 degree, this is 90 degree, so this angle is 30 degree. Then we can say that this component is equal to mg cos 30. This component equal to mg sin 30. Okay, and there is net motion in this direction, F net. Is there any doubt regarding this? This is just for showing our vertical and horizontal direction. One second. See, this is acting vertically downwards, right? So if you just drop this angle will be 90 degree. Okay, if this angle is 30, this angle should be then 60 degree, right? By like right angle triangle property. If this angle is 60, then if both are perpendicular, this angle will be 30. Instead of drawing there, we just drew here, that's it. Is it clear? Okay, now we will equate forces. So in vertical direction you can see only n and mg cos 30 is there. Object is not moving in this direction, so n will be equal to mg cos 30. Okay, normal force will be equal to mg cos 30. Why we are finding this is frictional. Static friction is equal to, sorry, not static friction, kinetic friction. Kinetic friction is equal to mu k into n, right? We need n, that's why we are finding it first. Now next, object is sliding down, so mg sin 30 is pulling it down, friction is opposing it, but it is moving with uniform velocity. Constant velocity means both are cancelling each other. So we can say that mg sin 30 equal to kinetic friction. Substituting these, okay, substituting this value here, we will get mg sin 30 equal to mu k into mg cos 30. Okay, is there any doubt till now? Any step? We have to find a mu k, so we just equate mu k equal to mg will cancel on both sides, and we will have mu k equal to sin 30 by cos 30. This is nothing but tan 30. Okay, then tan 30 will be equal to mu k will be equal to 1 by root 3. Answer. What about external force? This is not external force, net force. Net force is 0. How net force is 0? Because it is moving with the, okay, it is given that it is moving with constant velocity. If something is moving with constant velocity, net force is 0. That's why F net is here is mg sin 30 minus kinetic friction. Since external force is 0, we can write mg sin 30 equal to frictional force. We are getting that formula from there. Is it clear now? Okay. Then we will see the next question. Answer is like 1 by root 3. They have calculated the final form. Next is circular motion. In circular motion, majorly we will deal with centripetal force. Centripetal force equation you know. Centripetal force is equal to mv square by r. R is radius, v is the velocity of the particle, linear velocity, and acceleration will be equal to, this is tangential acceleration, okay, centripetal acceleration, okay, centripetal acceleration equal to v square by r. Centripetal means acting towards the center. Here one major misconception is that there is no actual force called centripetal force, like gravitation, friction. They are actual forces. Centripetal is just the name we give to the force acting towards the center. That force can be gravitation force. If earth is rotating around sun, the force that is pulling towards the middle is gravitation force. Now if you tie a stone in a rope and you are rotating, the force which is acting towards the center is tension. So there is tension acting as centripetal force, okay. There is no separate force called centripetal force. We just give that name to whichever force is acting towards the center. I hope that is clear. Okay. Then there is another force called centrifugal force. Centrifugal force is a pseudo force. Pseudo force means if you suddenly cut the string, what will happen? It will go outside, right? Even though we are pulling it towards the center through the string, once the string is cut, it will go outside because of this pseudo force called centrifugal force. Okay, example of centrifugal force you can see here. Okay, everybody is being pulled towards the center, but which direction they are all rising towards the outward. That is because of centrifugal force. Okay, now before going into circular motion much, our equations of motion are s equal to ut plus half at square, v is equal to u plus at, and v square minus u square equal to 2as. Rotation, circular motion have all these equations but with their analog. Okay, s will become theta, angular displacement. U will become angular velocity, initial angular velocity. V will become final angular velocity, and A will become angular acceleration, that is alpha. Okay, so our equations will look like this. Theta equal to omega I t plus half alpha t square. I hope you remember this formula. Yesterday we did a question with this. Okay, and v, u, omega f will become omega I plus alpha t. Then this is omega f square minus omega I square equal to 2 alpha theta. Okay, so our circular motion have same equations of motion as linear motion, only thing that we will take the like circular analog to it. Everything will be angular instead of linear. And similarly we have linear momentum, that is equal to m into v. If you come here, angular momentum is there, that is I into omega. I omega. I is moment of inertia. We will come to that in next class, that is rotational motion. And similarly here if we have force equal to ma, here we have torque, that is equal to I alpha. Okay, so every equation in linear motion has an analog in circular motion. Now, and some extra points that we need to know is that relation between v and omega. V is equal to r omega. Linear velocity is there, we will connect it to angular velocity. Linear acceleration equal to r alpha, radius into angular acceleration. Okay. Other than this, there is one more thing. In circular motion there are two types of acceleration. Okay. One acceleration, that is centripetal acceleration, is towards the center. Similarly, I can accelerate in this direction also. That is called as tangential acceleration. So, two types of acceleration, AT and AC, centripetal. This is also called as radial acceleration. So, we represent AR. Now, net acceleration will be equal to root of AT square plus AR square. Radial acceleration square plus tangential acceleration square, the whole root is our net acceleration. Okay, centripetal acceleration, every circular motion it will be there. But if the particle is moving with constant speed, tangential acceleration is 0. If the particle doesn't have constant speed, then tangential acceleration is there. Okay. Is there any doubt in this? Okay. Then let's see the next topic. Now, turning of vehicle in circular road. This is what we discussed yesterday. Okay. Now, there is a plain road, like there is no elevation, nothing. Just a circular road is there and a car is passing through it. We need friction acting as centripetal force. Okay. So, you can see this is the center, car is moving in this direction as shown. So, friction is acting towards the center. So, here centripetal force is equal to frictional force. Then we can see that mv square by r is equal to friction. Okay. And v is the speed of the vehicle. Is this clear now? There is no elevation, nothing is there, only frictional force acting towards the center. Okay. What is v equal to r omega? V is linear velocity, r is radius, omega is angular velocity. So, we are finding a relation between linear velocity and angular velocity. Similarly, a is linear acceleration, alpha is angular acceleration. So, linear acceleration equal to radius into angular acceleration. We are finding that relation. Okay. Is it clear? Okay. So, in this case, friction is acting as centripetal force. Next, so friction equal to, friction equal to mu mg will come, m v square by r, that is our centripetal force equal to frictional force. Then we can say that mv square by r equal to mu mg. Why mg? Because in this case mg equal to n equal to mg, friction equal to mu n, so friction equal to mu mg. Like that we will get. Okay. Any doubt? So acceleration A is equal to v square by r, that is just mu into g. From this you can find velocity v also. Not velocity, speed v equal to root of mu r g. Okay, so this is the maximum velocity in a plane circular rod, and centripetal force is given by frictional force. I hope there is no doubt in this. We will see the next one. Next one, there is a like elevation. I don't think you can see here. So the car is going through an elevation, banked road. This angle is like around theta. Then there are three cases when friction is acting towards the center. Okay. Second one, when friction is 0. Third one, when friction is acting opposite, outwards the center. This is why I said in banked roads friction is not necessary. There are three cases. One there where friction is not necessary at all. That's why in yesterday's question we selected only normal reaction is necessary. First case, when friction is 0. So mg is acting downwards. Normal force is acting perpendicular to the surface. Is the screen visible for you guys?
No, ma'am.
Okay. Okay, so this is the car. mg is acting in this direction. Normal force will act in this direction. Only these two forces are there. Okay. In that case, we can towards the center something needs to act. So normal force, we will find the components. This angle is theta. In that case, we will get this angle equal to theta. Is it visible now this side? Okay.
Yes, ma'am.
Okay. And here we will get n cos theta, and this we will get n sin theta. Okay. And from the diagram itself we can see n cos theta equal to mg, then n equal to mg by cos theta, we will find that and substitute in n sin theta. N sin theta is the one acting towards the center, right? So that will be our centripetal force. N sin theta equal to mv square by r. N we will substitute from this, so we will get mv square, centripetal force equal to mg tan theta. Okay. From this you can find what is v. What will be v? V equal to rg, root rg tan theta. This is how you are getting that formula when friction is not there in banked road. Can we ma'am, can you please explain from the turning of vehicle due to network issue? I didn't listen. When the vehicle is turning in a banked road, three cases are there: friction acting inwards, friction acting outwards, friction 0. Okay. When friction is 0, this is the case. You will get optimum velocity without friction also when there is banking. That is root rg tan theta. Okay. Next case, we will get the formula. Next case, when friction is acting inwards, so towards the center. So this is the direction of our frictional force. Okay. Now we are finding components of friction. Since this is theta, this direction there is f cos theta, this direction there is f sin theta. Okay. And n sin theta, n cos theta also we will get. Here derivation is little lengthy, so I am not going to do. Whatever we are doing, we are just equating n cos theta equal to mg plus f sin theta. Centripetal force equal to n sin theta plus f cos theta, and we will equate and we are finding the final result. Okay. So in that case you will get that maximum velocity that you can use is this. These are the equations that we are finding from the graph, means diagram. Okay. We have to use this formula. Is there any doubt in this? Like derivation part, you don't have to be like thorough, because there is no derivation required for this topic. I hope we can move to the next topic. Next is when friction is acting away from the center. Okay, so direction of friction will be this. This will be direction of friction. So again we will find components of friction. Components of friction in this direction and this direction and this direction. Components of friction.
Ma'am,
Yes,
can you please allow the class to be recorded?
it is recorded. It will be uploaded in the YouTube. Don't worry. Okay, so here we are taking friction away from the center. Again we will get formula for this. Okay, here this one and friction towards the center, there is a small difference only in the velocity formula. You can see the formula here. Okay, now there is vertical circular motion. Sorry if the image is not visible. Okay, in vertical circular motion, imagine that you are rotating something in this direction. Okay, in that case the velocity is not means the speed is not constant at every point. So this is like a topic you should read by yourself a little bit, okay, to understand. So at this point, what should be the minimum velocity so that it will reach till here? It will complete one rotation. That is our aim to find. Okay, so if we are rotating using a thing, there will be tension acting on the string. Okay, at this point minimum value of tension is 0. Okay, according to that we will derive and we will get a lot of values. And how we are doing the derivation is based on conservation of energy. At bottom point, kinetic energy plus potential energy should be equal to top point kinetic energy plus potential energy. Like that we will apply. Bottom we will assume that potential energy is 0, and applying that we will get the value of velocity at top and bottom. Okay, so this is the table that you will get at each position. What is velocity, what is tension, what is potential energy, what is radial acceleration, and what is tangential acceleration. Okay, is this visible for all table? I will send the class notes in group, don't worry. This complete PPT I will send to you. Okay, so at each point you have to know what should be the, like this is a minimum velocity so that it will complete one rotation, and every other things we are using potential energy plus kinetic energy same at every point. Only that equation we are using to find velocity at each point. Okay, then there are different cases for this. Okay, here there is no string, it is moving without any string, right? So here tension is replaced by normal force as centripetal force. When we are using string to rotate, tension is centripetal force. In these cases, normal force is centripetal force. Okay, so according to that we can make adjustments. Now let's try whatever possible questions we can. Let's try. Can you read the question? There are two inclined surface of equal length L, same angle of inclination 45 degree, and one of them is rough, one is smooth, which means rough is having friction, smooth doesn't have friction. A body takes 2 times as much time to slide down rough surface than the smooth surface. You have to find coefficient of friction. Okay, so this will be our diagram. There is there is a mass at top. This length is equal to L and this angle equal to 45 degree. So this is smooth surface, which means doesn't have friction. Okay, so only force acting in this direction is mg sin theta. This we have already did in inclined surface. Mg sin theta is acting in this direction. So we can say mg sin theta is equal to ma. We can substitute. From this we will get acceleration equal to g sin theta. Okay, and since distance and acceleration is there, which equation of motion we can use? Time they have given, but with the distance and acceleration, which formula is best to use? That we have to decide. Distance is there, acceleration is there, and it is starting from rest. So can we use s equal to ut plus half at square? Okay, so in first case it will be L equal to initial velocity 0, half acceleration equal to g sin theta and t1 square. First case. Second case, length is L, inclination is 45, no change there. Mg sin theta acting downwards, upward direction there is kinetic friction acting, and netted movement is in this direction. So here formula will be F net equal to mg sin theta minus kinetic friction. Okay, F net mass into acceleration equal to mg sin theta, and from the previous one I am direct taking the result that kinetic friction equal to mu mg cos theta. Okay, kinetic friction mu mg cos theta. I am directly taking the result. Cancelling m on every side, we will get here acceleration equal to g sin theta or g into sin theta minus mu cos theta. Substitute the value of theta as 45. Here also we got acceleration, but distance travelled is same, right? Length is L only. So here we will get L equal to half g into sin theta minus mu cos theta into t2 square. And L we will equate this equal to this, and 2 times as means t2 equal to 2t1. We will equate this equation to this equation and substitute t2 equal to 2t1, then we will get the answer. Is there any doubt in this question? Okay, here answer is equal to 0.75, and how we are getting that? We are using only one equation, that is s equal to ut plus half at square. In two cases, time difference is given, so we can just equate, like common is L, so we just equate them. If there is no doubt, we can stop the class for today. In this PDF there are more PYQs I have attached. Try to solve them. Okay. If you have any doubt regarding how to solve any PYQ, you can just message me. I will help you with that.